Welcome to another episode of Tech Unpacked, where we dive deep into the latest tools and technologies that are shaping the programming landscape. Today, we're exploring a fascinating library called Lo, which is a Lodash-style Go library built on the new generics features introduced in Go 1.18. This exciting development opens up new possibilities for developers working with collections, maps, and strings, among other data types. Now, if you're familiar with Lodash and JavaScript, imagine having that same powerful functionality available for Go, but with the added benefits of type safety and performance optimizations. It's truly an exciting time for Go developers. Let's kick things off by talking about why Lo was developed in the first place. It started out almost like a personal experiment. The creator, Samuel Berth, wanted to explore Go's generics and realized there was room for a library that combined convenience with the safety of static typing. So if you're coming from a JavaScript background, how familiar is that sentiment? It's that I wish I had something like Lodash for Go vibe, right? What's significant here is that the Lo library leverages Go's generics to provide a more efficient and secure way to manipulate collections. One of the standout features is its performance. Benchmarks show that Lo is significantly faster than other libraries that rely on reflection. But just how much faster, you might wonder? In a straightforward comparison with other implementations like GoFunc, Lo's map function is about 7 times quicker. It's not just about speed, though. It's also about how this library can help you write cleaner and more expressive code. One of the most impressive aspects of Lo is the variety of helpers it provides. Whether you're filtering, mapping, reducing, or grouping collections, there's a method for just about everything. For the listeners out there who may not be as familiar with functional programming paradigms, let's break this down a bit. Filtering, for instance, allows you to sift through collections and keep only the items that meet certain criteria. It's akin to having a fine mesh sieve that only lets the good stuff pass through. And let's not forget Lo's support for parallel processing. This is fantastic for maximizing performance and taking advantage of Go's Go routines. By leveraging these features, developers can write code that is not only faster, but also cleaner. Now, here is something that might pique your interest. Have you ever wanted to apply a transformation to a large dataset, but you were held back by the fear of performance hits? With Lo's parallel processing capabilities, you can accomplish that effortlessly. It's like having your cake and eating it too. You can execute tasks simultaneously without sacrificing the readability of your code. Another great feature worth mentioning is the extensive help it provides for handling errors, managing concurrency, and even channels. The Lo library can be a game changer for developers who are looking to write robust, maintainable, and efficient Go applications. But let's talk about future-proofing your work. Since Lo adheres to semantic versioning, you can be confident that when V2.0 rolls out, any changes won't disrupt your codebase significantly. This attention to stability is a breath of fresh air in a rapidly evolving tech landscape. To wrap things up, Lo isn't just another library. It's a toolkit that empowers Go developers to express themselves more efficiently. Whether you are interested in enhancing your productivity or simply looking to explore the new capabilities of Go generics, Lo is worth checking out. So, as we close out this episode, we encourage you all to take a look at the Lo library. Dive into the documentation, play around with it, and consider how it could fit into your own projects. What features do you find most